This is the story of the cooling tower seen there on the left, how we remove heat and condensate from the Syn-gas.
Okay, basically this is the inside of the cooling container or chamber. These four pipes come together in a manifold and come out as a single one up on top. As you can see, there's a lot of copper in this. Each one of these coils, which there are four of them, has about 24 feet of copper in it. So by coiling them together, as the gas comes up through it, it has a lot of surface area to be cooled or to come in contact with the gas to cool off. Through these we pump water, and we can recover some of the heat that is lost. It would normally just be lost, in radiation. We can now recover it and use it for anything from hydronic heating for hot water or whatever we want to use hot water for.
We built our copper coils by wrapping the copper on a simple mandrel, which we first had to lay out so that each one of the coils were the correct distance apart so that 24 feet of coil could be wrapped around each mandrel of different sizes. Then we wrapped the copper. Actually a pretty simple process. It went much easier than we thought it was going to. We had 4 different stages of mandrel sizes, starting with 3.5 inch, 4.5 inch, 5 5/8, and 6 3/4. This is the 5 3/5/8 piece. And then once the pieces were all coiled, we slipped them one inside the other, and that whole framework then slipped inside the cooling tower. And the 4 tubes get hooked up to this manifold. And there we have 96 feet of copper coil easily slipping within inside our cooling tower.
Water goes up in the top, the cold water warms up as it's going all the way down to the bottom. The hot gas comes out of here in at the bottom and is rising up at the same time past the coils. You have hot water, hot gas here. You have cold water, cold gas up here. So it's a counterflow design in this. We could easily reverse it and make it go the same way simply by reversing the flow of the water if we decide there's a reason to do that. But at this point I think it's probably prudent to keep the temperature ratios as close as we possibly can.
What's the bucket for?
The bucket is full of water, and you can see the water line on here where the bucket, once it's slid underneath, come over here and we'll actually install the bucket. Keeps the bottom of the chamber sealed with water. And the water that's in here allows all the residual tar and ash and things that are inside of here that are hot, still warm and dripping down to drip down into the bucket of water. We then, as the bucket continues to fill up over time, we can just siphon some of that off into a secondary bucket. The cool gas comes out of the gasifier, out of the cooling chamber, down into the fan. We have one additional trap here that if any tar or anything makes it out of this system, it comes in here, it'll run down the pipe and condense and then come out through and end up back in the bucket through this hose. The fan is a suction fan that drives the whole thing. It runs off 12 volt. This is an automotive car heater fan that has been modified with a heavier steel case on it. And this is a distribution manifold where we put the gas out to whatever we want to use it for.